Yeah, whatever you want to do.
Okay, awesome. Yeah, I think that's what the extra 3 minutes are for. Figuring out all the housekeeping. Awesome. Recording? Perfect. Hi everyone. I'm Advitya, and I'm an engineer at Microsoft in Windows, and I'll be chatting about LLM-powered merge conflict resolutions. So we're going to talk about the problems faced here, some insights on how we sort of customize LLMs for this use case. But more importantly, I'd really love to emphasize on some of the Python usage tips and tricks that are hopefully bite-sized for everyone, and hopefully is something that other people can sort of emulate, whether as coding patterns or as general design principles in their own projects. So I really hope this will sort of be fun for the audience. And so while we're on the topic of talking about things that are fun, let's talk about let's start with the most boring and annoying concept in the software development lifecycle: merge conflicts. I really hope all of us, in a way, are united towards our on our hate towards merge conflicts. So I remember back when I was interning in college, and this was during COVID, I was contributing to a machine learning library, and I was working on some deep learning methods, hyperparameter tuning stuff. And the most challenging part of my internship wasn't my actual project. It was basically fixing merge conflicts, where I almost needed hand-holding by other people in the team, where I was like, hey, I don't understand what this incoming code is supposed to do, or who wrote this code, or what it's used for. How do I kind of resolve this conflict to make sure that my user intent is preserved, along with their user intent, which is conflicting with mine, supposedly. And this looks like a simple enough merge conflict, but it can get really complicated with semantic conflicts, where you're trying to infer the intent of what the incoming change is trying to do, and how do you sort of resolve conflicting pieces of code or functionality. Broadly, out of a study done on open source projects, 1 out of every 5 PR merges causes a conflict. Even in the era of agentic AI, this percentage is not decreasing. Even with datasets like Agentic Flicked, which has conflicts from 142K plus agentic PRs, even they found a 27% conflict rate. So merge conflicts are not going anywhere, even in the era of agentic coding. It takes an average of 6 minutes to resolve a conflict, including understanding it, then resolving it, testing your changes. But at worst, it can even take days, especially if the way you resolve the conflict is incorrect or leads to any future regressions down the road. 75% of conflicts that are seen out there tend to be semantic conflicts, which require some level of logical reasoning to actually try to fix them. And areas where conflicts happen, even after fixing them, tend to have orders of magnitude more chances to lead to bugs and regressions down the road. So here's the background that we're dealing with. LLMs don't actually know how to fix conflicts in their pre-training. Even though with research that's been happening, there have been new data sets dedicatedly on merge conflicts that have been coming up. But ultimately, what it comes down to with fixing a merge conflict is user intent and what you want to do. To kind of support this claim, there are AI-powered merge conflict capabilities that exist out there today in modern IDEs and such. And I have linked some of those examples here. I have also gotten to use some of them. The UX is great. But when it comes to semantic conflicts requiring user intent, where it's really only you who sort of know what needs to be done there, those are areas where large language models tend to be quite inaccurate, or they just don't have that kind of context. In a larger scale, in larger projects, knowledge can be compartmentalized in terms of upcoming feature plans and what the intended behavior should be. getting wrong resolutions and then fixing them later can in fact slow you down. In fact, earlier this year, a friend of mine commented on a group chat just ranting about how using coding agents has not been ideal for them, to be more polite here, in terms of resolving merge conflicts. And I removed the name of the coding agents just because I don't want to badmouth any products. But you can kind of imagine some of the most popular coding agents that exist out there that were probably mentioned. At the scale of really large companies, or like large repositories of software projects, merge conflicts don't just bog down developers in their day-to-day, it can lead to massive delays during like CI/CD and release, and dealing with regressions in production. And from my personal experience looking at like merge conflicts in essentially like the largest Git repo on the planet, I have seen merge conflicts well into like 3 digits, sometimes 4 digits, every week and such. It can take a few days to resolve all of those conflicts manually, and it can just take a lot of developer time, even with the senior most engineers. And so we sort of tried to set out on this project of, hey, can we have AI try to fix this? Or can we teach AI the patterns that, let's say, human developers typically use to fix conflicts in our specific domain or project? And so this kind of makes me jump to the next section with a few high-level sort of insights that I got in terms of customizing LLMs